Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of the Pythagorean Theorem on a coordinate plane. This is standard 8.7D in the great state of Texas, and we are using item number 3 off the 2016 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have point M located at 4, 6 on a coordinate plane. All right, so here's my 4 and then my 6. So let's get that going right there. All right, so I'm just going to label that M. Then point M is translated 8 units to the left and 9 units down. Okay, so 8 units to the left is going to get me to -4. And then I'm just going to kind of put a little dot right there to keep track, and then 9 units down, so that's going to get down to -3. All right, so this is M prime. And we need to find the distance. Well, not sure exactly because it's not going to be exactly even then it's a diagonal. You know what? Look what I did right here. I actually used that as an intermediate since it was so long. And guess what this forms? When you're translating directly to left and directly down, you are actually making a right triangle. I know how to do right triangles all day long. I'm going to use my Pythagorean theorem. A squared plus b squared equals c squared. And so I've got my 2 legs of my hypotenuse, and they are labeled A and B. So I'm just going to label those. And then my C is always directly across from the right angle. That is my hypotenuse. And what A squared plus B squared equals C squared lets me know is that if I were to take that B, turn it into the side of a square, and get the area, that would be B squared. Do the same thing with A. I'd be off the chart a little bit there, but let's pretend that's a square. If I were to add up my A squared and my B squared, my 2 areas, it always equals, that's also off the chart, the area of my hypotenuse squared. So what is the side length of this B? Well, B was translated 8 units to the left, so that's going to be 8. So I'm going to rewrite this. So my B squared is 8 squared. My A was 9 units down, so it actually gave us the 2 side lengths. So that's my A squared, and that's going to equal my C squared. All right, so that's going to be 81, and that is going to be 64 equals C squared. So I'm going to need to add those up. And what am I going to get? Let me see. Pull out my calculator in case it gets a little bit wild with our exponent. Maybe it won't. But 81 and 64, that's 145. All right, so yeah, that's not exactly a perfect square, but it's really, really close. Because I need to take the square root now. That's how you get rid of that exponent. So the inverse operation of exponents are roots, and so since it's c squared, I'm going to take the square root, but I have to do that for both sides. But I need to take the square root of 145. Now, if I wanted to, I can use my calculator, and this is what we'll get, right? We'll get c equals 12.04159, and it keeps going. It's an irrational number. But we also could have just done that without the calculator. Look at that. It says it's closest, so it doesn't have to be exactly perfect, right? And I know that the square root of 144 equals 12. So if I'm looking for the square root of 145, it's going to be 12 point something something, very small. Either way, our answer here is D.